Hello! Today we're going to be talking about the other extreme environment besides glaciers where we see a lot of effects of weathering and erosion: deserts. So, a desert is just defined as anywhere that gets less than 10 inches of rain a year. So your brain probably automatically goes to like the Sahara Desert or maybe the Gobi Desert. It also includes all sorts of different terrain types. It doesn't have to just be a big sandy area, although that's what we see most often. Antarctica is actually the world's largest desert. It's so cold there that the air can't hold any moisture, and so it doesn't really rain. We also see like the Atacama Desert in Peru is right along the mountains along the coast there, and so you can have mountainous regions that are deserts. Really, it's just anywhere that doesn't get a whole lot of rain, and that's going to have a huge effect because of how important water is. In the US, our weather patterns move from west to east. And so when we think about the West Coast, if we think about like California and beyond, moisture is going to be brought onshore from the Pacific Ocean. The wind is going to take all of the moist air from the ocean and push it to be overland. But then we have some mountains right off the coast, and the mountain ranges are going to force all of that moist air up, and it'll rain, it'll precipitate, or snow, or sleet, or hail, or whatever in the mountains. On the other side, all of that air will come back down from the mountains, but now it doesn't have any moisture in it anymore. It rained or it snowed and it lost all of the moisture, and so the air coming down now is really dry. So we often see in the US deserts on the leeward side of mountains, that is, on the side of the mountain farther away from the ocean or the water source. The main thing that's going to cause problems in desert is going to be water. Both the normal lack of water and the fact that when it rains, it pours. When there is rain, it tends to be a lot and it tends to be very sudden and very heavy. So we see a lot of erosion from flash floods. Erosion is a huge problem or comes up a lot in the desert because, one, there's not a whole lot of vegetation. Plant roots tend to hold the soil together, and if there are no plant roots, there's nothing to hold the soil together. And two, the soil is already loose. We see larger grains of soil, of sediment in the desert. It's not so much the like really fine soil or clay that you might be used to in your backyard, but it's bigger grains of sand which don't compact as well. They have more space in between all of the grains, and so it tends to be very loose and spread apart and easy to move. So we see a lot of erosion. We don't see as much weathering. It's a little bit harder to break the rocks down. It's easy to carry them away. It's not as easy to break them down. We don't see a lot of chemical weathering caused by chemical reactions, again, for two reasons. The biggest one being there's not a whole lot of water. If there was a constant source of moisture, water is the driver for a lot of chemical reactions, specifically a lot of chemical weathering. Rust, salinization, salt, acid rain. If you don't get a lot of moisture, you don't have the means to do chemical weathering. And two, there's not a lot of plant life. And so without plant life, you don't get some of the organic acids that can also cause rocks to break down. So we don't see a whole lot of chemical weathering. We'll talk about mechanical weathering in a second. We do see a lot of erosion, mostly caused by water and wind. When water does come, like I said, it comes sudden and it comes fast. And so we can have streams or lakes that form in deserts, but most of the time they don't last very long. They are dry for a majority of the year, and then there's a sudden rainstorm, and now we have a stream. That's called an ephemeral stream because it doesn't last for very long. Typically, they won't have running water in them until it rains. Because there aren't really these permanent streams, they aren't going to flow all the way out to the ocean when they do form. Something like the Colorado River or the Mississippi or the Nile or the Amazon, all of these rivers are constantly full, and so they flow all the way out to the ocean or to a sea. Ephemeral streams are not constantly full, so they will flow, but only within the desert. They won't make it very far out of the desert. And so we call this interior drainage. Again, seeing this in the US, we have a region called the Basin and Range that is made up of these alternating mountains and valleys. This is in like the west and the southwest of the US. It includes the Death Valley, and it is a really kind of classic example of interior drainage. You can see with these mountains and valleys alternating back and forth, we're going to have deserts all throughout this area, and when there is water, it won't really have anywhere to go. A couple of key features that we see, kind of things that pop up often in interior drainage areas like the Basin and Range. One of them is going to be a playa lake. This is specifically a very small lake that forms in a desert during a flash flood event. It will only last like maybe a couple of days or weeks, but then it dries up. And when things dry up, they tend to shrink. And so the mud will shrink, and you end up with these big kind of like slabs, these cracked chunks of mud and sediment. Lots of times we see salt left behind in these, so salt flats often form in deserts, and it's a good place to find and mine salt because you end up with these cracks at the bottom of a playa lake, or what was a playa lake. Other interior drainage features we see include an alluvial fan, which is a very large and fan-shaped deposit that you see at the mouth of a canyon. This is going to be where we were going down the mountain, rain was falling at the top of the mountain, and suddenly it stops being steep and it starts being flat. And so the sediments that were coming down with the rainwater don't really have anywhere to go. They all of a sudden are now flat, so they deposit themselves only a short distance away from the slope. And so we see, like I said, the Basin and Range. We've got deserts and mountains kind of going back and forth. And you'll notice in the picture, the very top picture, what it looks like now, there are a couple of playa lakes, and you can see some alluvial fans where things were coming down the mountain and then spreading out. But if water is coming down the mountain and bringing sediments with it, then it's easy to imagine how eventually the mountains are going to be slowly carved away. That water, every single time when it falls, is carrying sediment, is carrying rock down with it. And so the mountains are shrinking. And so eventually it'll get to the point where it is flat and just desert. So water is a huge, huge driver of weathering and erosion when it does happen in the desert. The other main factor is going to be the wind. In really humid areas where it rains more often, you have moisture in the air and you have vegetation. So wind erosion doesn't have as big of an effect. In the desert, the wind can pick up. We have talked before about in a big flat area, the wind is able to pick up speed really quickly. It doesn't have anything to stop it. It's not running into houses or trees or forests to slow the wind down. So in a desert, wind can get really, really fast. And it will pick up the finer sediments, the smaller grains of sand, and carry them in the air. The larger things will kind of bounce along the bottom. They'll still move, just not kind of as dramatically. And in fact, we see this in a process called deflation. The lighter stuff, the looser or finer sediments, the tinier grains of sand, will get picked up by the wind and carried away. And all of the heavier stuff maybe will bounce along the bottom. We call that saltation, but it's going to sink. And so all of the light stuff gets carried away. All the heavier stuff is left behind. It sinks to the ground, and we get desert pavement. We get to a point where deflation has ended. All of the light stuff has been carried away. And so all that's left are the pebbles or the cobbles, the larger chunks of sediments that have sunk now to the ground, and the desert is essentially covered in pebbles. The sand doesn't just disappear, though. The sand isn't gone. A lot of that sand will form dunes. Maybe you've seen or heard about dunes before, but these are absolutely massive piles of sand, and they move. They can move up to 15 meters or about 50 feet in a year. they are very much not random piles. It's not like you're at the beach and digging a hole and just throwing the sand wherever it is. They have very consistent patterns based on a couple of different factors: the direction of the wind, the speed of the wind, how much sand there is, and if there's any vegetation present. So we'll see there are a couple of different types of dunes that form based on these factors. The first type of dune we see is called a Barken dune. These have a crescent shape to them, and the tips of the crescent will point downwind, or they'll point in the same direction that the wind is going. Here, the blue arrow is showing wind. These form in areas where we don't have a whole lot of sand and we don't have any vegetation or a whole lot of vegetation, and we'll have a pretty constant wind. This picture is actually of Barken Dunes on Mars, where there's no vegetation, but there is a fine layer of sand over some areas on the planet. The second type of dune is a transverse dune. These are huge, long ripples that form perpendicular to the wind. They can be 200 meters high, or like 600 feet high, and 1 to 3 kilometers across, so multiple miles long. These form in areas where there is abundant sand, a lot of sand, but not a whole lot of vegetation again. Remember, that's going to be a kind of common trend. In a desert, you don't see a whole lot of vegetation. Third up, we have longitudinal dunes. These are going to be long ridges that form when you have wind coming in from two converging directions. So two gusts of wind that are starting to point in the same direction. And this will be in an area with not a lot of sand. That is longitudinal dunes. Again, these are going to be really long because the wind is blowing from both sides. But you don't have a whole lot of sand, and so you don't get big, giant ripples or fancy structures. Next up are parabolic dunes. These are also going to be crescent-shaped, but they are opposite from the first one. They are opposite from Barken dunes in that now the crescents, the tip will point to where the wind is coming from. These form in areas where the sand has more moisture in it, and where there is some vegetation. These ones are kind of the odd one from the bunch. Beaches are where we will often see parabolic dunes. The last final type of dune is going to be a star dune. These tend to be much more isolated peaks. They look maybe more like a mountain. They can get really tall, again, 50 meters or 150 feet tall, or even more. And they form where there is variable wind, where the wind can be coming from any which way depending on the day. This is what we often see in the Sahara Desert. So here they all are combined. You can see that if the wind becomes consistent enough, Barken dunes can kind of transform into transverse dunes, and they all have kind of their own looks to them. So different dunes that form in different areas, depending on the wind, depending on the type of erosion that's happening. So there's what you need to know about weathering and erosions in deserts, including our own deserts in the US, the Basin and Range, and how wind can create some incredible features within deserts. That's all for these notes. Bye!